طيب بسم الله الرحمن الرحيم. So last time we started to talk about radio resource management. We talked about radio resource management as one of the most critical يعني area for how to manage the radio resources in any cellular systems. Today, inshallah, we'll start to talk about the details of the standards, starting from second generation wireless all the way لغاية يعني to 4G. So when we talk about the details of the standards, you will be overwhelmed with the terminology. I got to really warn you that you really have to try to memorize some of the jargon and the abbreviations and the terminology that we will discuss as part of this chapter. There's a huge amount, but they are really useful, especially for those of you who want to work in the telecom domain. I think this terminology is really useful, and you need to memorize them. So of course, global system for mobile. So this is like a map or a graph that shows the evolution of the wireless telecommunication systems. The x-axis here, or the horizontal part here, shows the generations chronologically. Okay, and here we focus on the multi-axis technology. Okay, so when we talk about first generation was purely analog, so there was no digital domain to process any kind of digital data or anything like that. There has been no analog to digital or digital to analog whatsoever. So everything was in the analog domain. So the only multi-axis method that was used was FDMA. So we know how to use FDMA in analog domain. So you just divide the spectrum into channels, and each station would have like a range of frequency or one channel dedicated to it. So there's you cannot even do like dynamic channel allocation. You cannot process data, in the digital domain, because it's purely analog and so on. So the most, the only one that was kind of, famous here is AMPS. There's nothing to talk about here, nothing much. So starting from second generation, we started to have digital cellular systems. So you have digital amps. You have the predominant standards in second generation was by far global system for mobile, GSM. So GSM came with actually a revolution. Not only does it transform the data into the digital domain, which facilitates all types of processing for introducing error recovery, reliability, and so on and so forth, but also it introduced for the first time the concept of handover and mobility. And that was quite a revolution. So the fact that a mobile station can move across the entire network, which spans a country, and actually move from one country to another and still have no service disruption, this was quite a revolution at that time. Of course, nowadays we kind of take it for granted, but in the past, in second generation, it was a huge upgrade at that time. So global system for mobile, as we have studied before, it's based on FDMA, TDMA, both together, and it uses some kind of dynamic channel allocation. So it actually divides the spectrum into channels and time slots, both, right? So each resource block is like a time slot in a specific frequency range, and this time slot for a specific frequency range gets assigned dynamically to the mobile stations. So we'll talk about the details of this in a later stage. GSM came into the picture to try to improve the mobile services. However, mobile services was actually used first and foremost, as we have discussed before, for voice calls. Before the mobile cellular systems, we used to have the telephone lines, or public switch telephone networks, PSTN. Public switch telephone networks, they use the wired phones. So you have switches, and it's purely circuit switched network, which is based on set of switches and lines. So when you try to make a phone call, you just get established a physical circuit throughout all the switches from the source all the way to the destination. So this circuit will be dedicated for you, right? So for GSM, the idea here was to try to provide part of this call as wireless. So GSM provided wireless connectivity to mobile stations to facilitate the mobility and the portability of these wireless devices. But as we will see, this is only one hop from the mobile station to the base station, and after this, everything else is wired. So it connects the core network of GSM to the public switch telephone networks through lines, through physical lines, as usual. Because of the fact that GSM was mainly designed to establish voice calls or to support voice calls, the support for data services, and I mean like data transmission, in GSM was quite primitive. So the data rates that GSM used to support was extremely low, in the range of like 10 kilobits per second. And of course, for us nowadays, this is a big joke. But at that time, it was not the main objective of GSM. GSM came with the main objective to provide mobility, handover, and roaming for mobile stations across different location areas or cities or countries or something like that. But it does not really mean that GSM came with the objective of providing high-speed data transmission. That was not the objective at that time. Because of the fact that GSM came to support voice calls, the main service in GSM was connection-oriented. So because in connection-oriented, you can provide some kind of reliable service and deterministic behavior, which really aligns with the voice call service. In voice call, you need to have like some guaranteed quality of service. GSM supports connection-oriented services, as we will discuss in a minute. And that's on top of circuit switching as well as packet switched networks. So horizontally, when we move from the one generation to another, we will witness a huge milestone that requires complete replacement in some cases, or significant amount of replacement to the infrastructure in terms of not only software but also hardware. So when we talk about first generation and from first generation to second generation, there is huge amount of infrastructure replacement. So all the servers have to be replaced in terms of hardware and software, right? So this is very important to know. Because in between the generations, we might have like a 2.5G. For 2.5G or 3.9G, so these are releases of some standards, which requires, in many cases, some upgrade in terms of software, but not really significant replacement in terms of hardware. So the idea from 2G to 2.5G was mainly to increase the support for data transmission. That was the main objective, right? Because data transmissions for GSM was quite primitive, was quite low, and the idea for 2.5G is only to add more data services on top of the GSM infrastructure. So for GPRS was the first kind of upgrade to GSM to provide high-speed data transmission. It's called General Packet Radio Services, GPRS. This was the first generation. Maybe some of you maybe have used this in senior project or course project in the undergrad. But of course, this is very much obsolete now. And then Edge also introduced another software upgrade to GSM, which provides even higher data services. But then the third generation, 3G, came into the picture with the introduction of what we call IMT 2000. This IMT 2000, we will talk about it. IMT 2000 introduces the first set of requirements for how 3G should provide. So these are the requirements. So the standards first, they come up with a requirements document. This requirements document usually is like a multi-thousand page document which states in details what the physical layer should look like, what the data link layer should look like, and so on and so forth. And then they receive some proposed standards for the design of how the standards will be implemented. And then they go into rounds of refinement on the standards until they finalize, and then they stamp this as, this is like an acceptable standard document that aligns with all the requirements. It meets all the requirements. And the most famous proposed standards in 3G was the UMTS, or the UTRA, which we will talk about as part of the course. We'll talk about the details of this. And that actually used, in terms of multi-access, it used CDMA, as we have discussed before. So CDMA was a revolutionary technology at that time that provided better spectral efficiency compared to, of course, FDMA and TDMA because of the orthogonality of the codes, as we have discussed before. And that was quite an upgrade and facilitated the fact that we can support higher data rates and more higher quality in terms of voice calls for 3G. Okay. So although there was another stage 3.9G LTE as part of the 4G standards, however, they called it 3.9G because the LTE was not, or did not actually align with all the requirements in 4G. So it's not until LTE Advanced, which is another release of the standard that meets all the requirements for 4G, and they stamped the LTE Advanced as the fourth generation standards that aligns with all the requirements. And of course, at that time, LTE, we see that it goes back to FDMA, and because it actually uses a different technology for multi-access method, which is ايه بقى حد عارف؟ OFDMA. So OFDMA is actually FDMA, but in that case, FDMA actually divides the spectrum into channels with some guard bands, right? So the spectrum can be divided in limited number of channels, obviously. So as we will see in GSM, for example, the maximum number of channels is like 124 channels, okay? With guard bands in between just to facilitate or to mitigate the interference between the neighboring bands. OFDMA, on the other side, it actually squeezes the channels into very, very small sub-channels. We call them sub-carriers. and they rely again on orthogonality in the frequency domain, not that in the code domain, which was also quite a revolution at that time. So in that case, you could potentially have thousands of these subcarriers in the spectrum. It squeezes the spectrum into thousands of these subcarriers, so you can assign smaller subcarriers to the different mobile stations to provide high speed. Of course, each mobile station, of course, can use multiple of these subcarriers to provide high data rates. Okay? Of course, in that case, VOF-DMA does not suffer near-far effect and all the stuff that we talked about in CDMA. So it was, at that time, it was, of course, a big evolution towards high data rate transmission. ماشي كده? So this is the whole picture. Of course, we will take each one of these standards and we'll zoom in and we'll start to talk about each of these standards in more details. Okay, so any questions so far? I forgot to say here that in addition to the milestone generations, you will see like other standards here that many of them, they actually, they arise and then they disappear without strong adoption from the international community. So these are the ones that we highlighted now are the ones that were actually adopted by the international community, starting from GSM and GPRS's Edge and the UNTS, which are the ones that we will talk about, and of course LTE Advanced. Okay, so these are some of the trials that were developed sometimes in the States, in Japan. Because some of these countries, they used to try to single themselves out from the international effort towards developing standards. They try to have their own development of, proprietary standards, I should say. But then, the international community did not adopt these, proprietary standards, and hence they have not really found their way towards being, an international standard. So even some of them were actually trying to promote for CDMA early on in second generation, as you can see. But these have never, been, adopted widely throughout the international community. So GSM, of course, until a few years back, GSM was the predominant standards worldwide. So the number of subscribers for GSM was by far the largest pool of subscribers for any telecommunication system. Of course, that was superseded, of course, now by 4G and 5G as we enjoy today. So Global System for Mobile was actually founded by ITSI. ITSI is the European Telecommunication Standardization Institute. This was in Europe. So in Europe, they started this effort early in the 80s, and they started to have a big group to try to standardize GSM or second generation. Again, was the objective of trying to have roaming and mobility and handover and so on and so forth. So they introduced GSM as the second generation. GSM was the first, very, very successful model for international unified standards, which have been adopted by all the vendors worldwide. So even, some efforts, as we said before, in US, in Japan, to try to develop their own and try to force everyone to adopt it. This was actually, did not really succeed very much. So GSM have actually evolved as the international standards, and that actually forced everyone to get into GSM development. Even all the vendors in the US and Japan, they started to adopt GSM later on. So they actually later on formed an international body, not just by European, an international body. It's called 3GPP. Okay, a global partnership program, or the third generation global partnership program. And that 3GPP is currently the international group that is responsible for standardizing all the telecommunication systems until today. So these are the entities that developed later on 3G, 4G, 5G, and now they are working on 6G. And there is also another proposal for 7G in a later stage. So today, by the way, we'll have a seminar by someone, by Dr. Ala. He will talk about 5G and 6G and how they look like, because obviously in the course we will not cover these. So, some of the performance characteristics for GSM, the first and foremost, mobility, of course. Of course, the GSM came with the main objective of supporting voice and data. However, data support was very, very introductory. It was very primitive, like 10 kilobits per second. Because remember, 10 kilobits per second are enough to carry our voice. Okay, so if you sample our voice signal from analog to digital, and then you code it and you do all kind of video codecs and stuff like that, 10 kilobits per second are more than enough for our voice. So they standardized channels of transferring or being able to transfer 10 kilobits per second per session or per channel. So this was quite enough for voice. However, for data, of course, as we all know, we need diverse set of data services, and we need, of course, higher data rates than that. So the total mobility here means that you have an international identity. So the mobile station now has identity which works international. So I actually experienced this firsthand. In the past, I used to travel from Canada to the States through the borders. So I used to, use some services, and while crossing the border, you have no service disruption whatsoever. So you see, you are roaming from one country to another, but the service stays with no disruption. And you have an international identity, and you can roam from one network, which is, two networks which are supported by different vendor, different telecom service provider. So the chip card or the SIM card has identity, and we'll see how this facilitated through the GSM architecture, how your identity moves from the home network to the visitor network, how the roaming happens. We'll see how this is done. So you have worldwide connectivity, and you have high capacity. High capacity here refers to the fact that high capacity doesn't mean any high data rates. High capacity here means that you can, in fact, support dense user equipments or dense of mobile stations in a small geographical area. And of course, this is facilitated through the concept of small cells. We talked about that. So the concept of small cells allows you to have high density of users in a small geographical area. So in that case, you can have smaller cells, and you can have sectorized antenna, which again in a small geographical area allows you to have antenna diversity, and you can use different frequency and different directions for the antenna to try to increase the density in certain areas. So higher transmission quality for the audio. This is actually facilitated through the digitization of the signal. So of course, in analog, the only thing we could do is just to use filters, and that's it. We didn't have the ability to provide any kind of sophisticated processing on the signals because they are in the analog domain. But now GSM came with the concept of digitization. So the signal is, in fact, in the digital domain. So in the digital domain, we can provide error coding and forward error correction and reliability and all of this. So in the digital domain, you can provide all kind of sophisticated processing, which allows you to have high quality voice and so on. واضح so far? Of course, in addition to this, of course, we have security functions. So we have access control, authentication, the main pillars of security, which are supported through the SIM card with all kind of IDs and which are being used for authentication, for key generation and stuff like that. We'll talk about this details as well. So GSM offers several types of connections. We have voice connections, we have data connections, and we have what we call a short message service, SMS. So we are aware of SMS. SMS came with this in the standard, actually, in the beginning of the standard. It was standardized with GSM, but for some reason it was not used until maybe like 5-6 years after. The support for SMS as part of GSM was quite interesting because they have used the control channels to provide SMS short messages. So the control channels are used for signaling usually, right? So they have used the control channels to send short messages. And they put this in the standard, and somehow it got adopted like 5 or 6 years until they have realized that there is some hidden service in the standard that they can use. And in a later stage, SMS until today is being used for many, many governmental services because of the fact that since it's used through the control channels, they have very high priority and really reliable. They provide a reliable service. So it has been adopted and used widely, even until now. So even now we have advanced WhatsApp and so, but still SMS is being used by governmental services widely. تمام كده؟ So okay, so to get to the bottom of it, so GSM provides 3 different types of services. Okay, the first one is what we call the basic service or the bearer service. We call it the bearer service. Bearer service here provides the basic service based on connection-oriented services in the lower layers. Layer mainly 1, 2, and possibly 3 as well. Okay, so basically, so if you have كده يعني 2 mobile stations, this is a mobile station, this is a mobile station, and they are communicating together. So you have the application layer here. We'll talk about this in the other 2 services. So application layer here are provided through these other services. And you have here layer 1, 2, and 3. Layer 1, 2, and 3. So these are the bearer services. And possibly it comes again with IP, because also cellular networks, they use IP. So the bearer services as part of GSM is the basic service that you have to provide. It provides again connection-oriented service, okay, in the lower layer, which means that includes all kind of physical layer functions and data link layer functions, right? So in terms of error control, flow control, channel coding, and so on. So this is as part of the bearer service. So when we talk about bearer services, this is the basic radio service that takes care of all the wireless transmission in the physical layer and data link layer, and also the network layer 1, 2, and 3. So this is the basic. On top of it comes any kind of a application layer service. واضح كده? So this is the bearer service. So as you can see here, this is the bearer service. So from the mobile station to the other side, this is what we call the bearer service. Okay? So here you have what we call mobile terminal. Okay? So this mobile terminal provides the lower layer function for the mobile station to have any kind of data service in the lower layer. واضح كده؟ So this is lower layer transmission. ماشي كده؟ So this is the bearer service. On top of this بقى you could have the terminal equipment, TE, the terminal equipment here, and the terminal equipment on the other side. This actually provides بقى the application level service. Application level service يعني several applications بقى يعني مثلا fax, voice calls, caller, anything. So all kind of application level services, they are supported through the terminal equipment. Okay, so the terminal equipment interconnects with the mobile terminal to provide lower layer radio services, and then it goes back through the network. When it goes through the network, you have what we call the UM interface. We'll talk about this. We'll talk about the UM interface. So the UM interface provides the interface between the mobile terminal and the core network. The GSM core network is composed of base stations and base station controller. We'll talk about this. So this is the core network of GSM. We'll talk about the architecture of how this core network looks like in a minute. So this core network manages all kind of radio resource management, mobility, handover, all these functions, right? And then it actually continues to the public switch telephone network. As we have discussed before, GSM connects with public switch telephone networks. Originally was designed to do this. However, you could, of course, use GSM to call another mobile station, in which case you have another type of core network, which could be another GSM network or any other type of network. And on the other side, you have a terminal equipment for the other destination so that you can have an end-to-end service. So the connection to the public switch telephone network has been defined in the standard as a native support. Yani it's native. Yani the PSTN is seamlessly connected with GSM. But of course, you could also use GSM, and we'll see which part of the architecture, which is being used to facilitate the communication with another destination network, which could be another service provider for GSM, or I don't know, like 3G بقى, or any other CDMA network, or any other core network of any type. Okay, so this is facilitated through a component in GSM, which they have defined in the standard, and based on the destination network, you need to define this component according to it's like a bridging between the GSM network and the other destination network. But the support for PSTN, as I said, came native into the standard. ماشي كده؟ Any questions so far? شوفي هو as I said, until a few years back, GSM subscriber pool was the largest in the world. Nowadays, of course, some of these terminologies have changed, but you will see that through 3G or 4G, many of these terminologies and concepts have been maintained. Yani the concept of base station transceiver, base station controller, mobile switch center, and so on and so forth. Many of these terminology, you will see that they have been maintained in 3G and 4G, and even in 5G. Some of it have remained through 5G. The architecture itself for GSM have been used for 3G and 4G and so on, although of course with some changes, and some technologies have been completely replaced. So that's why really studying GSM is important, because it gives you the foundational requirements for how 3G and 4G came about after this, right? And many of these terminologies, when you know the history of it, it kind of gives you, more sense that, the foundation is actually the same, and they have upgraded and, did some development in certain components and certain parts of the architecture. But again, to answer your question short term, The number of subscribers for GSM has dropped dramatically after the adoption of 4G in particular. Okay, so I think the number of telecommunication service providers that still support GSM until today is really low. Although 10 years back it was really high. Okay. So the other types of services, you have telematic services. Telematic services these two services are application level services. Telematic services here refer to application level services that are mandatory in the standard. Mandatory in the standard. So you cannot comply with the standard if you're not providing these application level services. So voice calls, for example, fax, and so on. We'll talk about some of examples of these telematic services. Okay. Supplementary services. Supplementary here means optional. So these services are possibly developed, and if the service provider or the mobile station do not support some of these supplementary services, they still comply with the standard. However, having these services in the implementations of the telecommunication systems is in fact recommended, but it's not mandatory. Like مثلا caller ID. Caller ID, when it was introduced at that time, was one of the supplementary services. So even if the vendor or the telecommunication service provider does not develop or does not implement this in the actual infrastructure, they still comply with the standard. There's no issue with that. So that's the difference between telematic services and supplementary services. تمام. So the bearer services here talks about the telecommunication services to transfer data between the base stations and the mobile stations. The specification of this service up to the terminal interface supports the layer 1 to 3 as we have discussed. So the bearer services support both circuit switched and packet switched service. By circuit switched here we mean that in that case you deal with switches only. You don't have any routers, you don't have any packets being routed. So circuit switch here means that you establish a physical circuit, and this physical circuit remains active until you finish all the voice call or the transmission that you're doing. So circuit switched communication is of course more compatible with the voice calls. Okay. But as you can see that the data rates here is like 9.6 kilobits per second, which again is okay for voice calls. It's fine. You can have very high quality voice with this data rates. Of course, if you have synchronous communication, this means that the transmission is at predefined times. Okay, and you have asynchronous communication, which means that you can send at any point of time. So this is the main difference between the two. For packet switched, you can have data services or data transmission over this packet switched paradigm, and you have also synchronous and asynchronous, and in that case the data rates are the same, 9.6. So 9.6 is good for voice, but it's not good at least for the diverse data services that we have nowadays. So nowadays we can have video even over data transmission, video over IP and video on demand and all kind of video transmission, YouTube and so on and so forth. Of course, with these data rates, you cannot have any high quality data services. So طبعا today refers to when the book يعني was. So today we have 50 kilobits per second. Of course, that was wow at that time. But this actually, even this was supported as part of 2.5G, not GSM. So GSM alone cannot give you this 50 kilobits per second bitrate. So you have to have GPRS or Edge to have these high data rates. We'll talk about this. Okay. So additional services here refer to the some of the this is some of the non-voice tele services. Of course, the voice calls, we know that. These are also part of the telematic services, which are the application level services that should be there in the standard, and that includes voice mailbox, group 3 fax, and so on, and SMS. All of these are telematic services that should be part of the system. Otherwise, you're not complying with the standard. Okay. Type. So for SMS, we have, as we said before, short messages, and short here refers to only 160 characters message. But of course, nowadays we can send more than that. And what happens is that you can actually use segmentation and reassembly at the mobile stations to have multiple 160 character messages, which constitute one message. So you do segmentation at one mobile station and you do assembly at the other side to try to, this is what we call a EMS. So you have SMS. SMS provides 160 only, 160 characters. And you have enhanced message services. So EMS provides even more number of characters per message, and it uses some kind of a segmentation and reassembly. And you have, of course, MMS, multimedia message services, okay, which you can not only send text, but you can send also images, graphics, things like that. Okay, MMS is not as common, of course, because for MMS we can use WhatsApp, and you can use other applications to do that. Okay. Type supplementary services here بقى. These are services in addition to the basic service اللي هو البيرر and the telematic services, which are offered as standalone, and they of course ISDN is like PSTN. Although ISDN was supported for multimedia services in the past, and now it disappeared completely. So ISDN, you don't have to know much about ISDN. We studied ISDN when we were as young as you, but now it's totally obsolete. It's gone completely.
What does it stand for?
Integrated, I don't know, services for, I don't know, I can't remember. It provides some kind of multimedia services. Because PSTN was focused on voice. ISDN provides teleconferencing using multimedia, voice and video and so on. Okay, so at that time, ISDN was built again on the concept of connection-oriented and circuit switch to try to provide deterministic quality of service, right? So in a way, it kind of similar to PSTN. So GSM, when it was standardized, it provided native support for PSTN and ISDN. Okay? But of course, you can always call another GSM network or another type of network, even CDMA or something like this, as we said. Okay? Type. The important services here include the identification, forwarding of call numbers, caller ID, call forwarding. All of these are some examples of supplementary services. So caller ID, call forwarding, all of these are supplementary services. If the vendor chooses not to develop these services as part of the infrastructure, they still comply with the standard. But they exist just to provide some kind of a diverse application level services which users can enjoy. ماشي؟ طيب. The architecture of GSM system includes اللي هو بقى core network. The architecture of the core network includes what we call PLNM, or public line mobile network. We'll talk about بقى the details of this, and I will try to show you some animation from assignment 3. So several providers, they set up the mobile networks following GSM standards. So you have the components and subsystems. And as we see that this architecture, by the way, is kind of nice because it gives you some idea how to really design an architecture for your system. It's a good style to try when you design a system for any project, even for senior project or for master or PhD. If you work on a system level work, it's kind of nice to try to think of this system as subsystems, and in each subsystem you have components, and how can you interconnect these components in such a way that looks scalable and looks hierarchical in a way that provides services more efficiently. We'll see how they did this. So you have some components and some subsystems. So these subsystems, they divide the core network into 3 main subsystems. Each subsystem has one or more of these components. Okay, so we'll see how they look like graphically now. So in the component level, we have what we call mobile station, which are with mobile stations. These are our mobile stations. These are divided into 2 logical components, اللي هم الايه terminal equipment and the mobile terminal. Terminal equipment provides application level services, and the MT provides the lower level radio services that connects the mobile station to the core network. تمام كده؟ And you have the base station or base station transceiver. This base station provides بقى the basic radio services to the mobile stations. These base station transceivers, these are located اللي هم towers these are base station towers that are located in different geographical locations to provide some kind of a one hop radio transmission to the mobile stations. To facilitate the mobility, we have what we call mobile switching center. The mobile switching center manages the mobility of the mobile station from one location area to another. Okay, so if the mobile station moves from one location area to another, then you have to trigger the mobile switch center to manage the handover process. And this handover process is quite complicated, as we will see, because you have to remove the resources from one base station and then introduce these resources to another base station to provide some kind of a seamless service without any service disruption. And that requires synchronization, require really careful design of how you provision the resources on both sides to cause no service disruption. We'll see this process is really sophisticated. And you have location register. For these components, we will see that we have multiple subcomponents as well. So you have the location register. Location register here stores very critical information about the mobile station. Some of these information is semi-permanent, such as مثلا the serial number or the mobile switch identity number. We'll talk about these numbers. Some of these numbers are semi-permanent, and some of them are, temporary. Like, where is this mobile station now? Where does the mobile station exist at this point of time? So when it moves from one location to another, this location has to change. So maintaining this information requires managing semi-permanent data and temporary data at the same time. And you have multiple databases to maintain these types of information. In terms of subsystems, we have the radio subsystem, and you have the network and switching subsystem, and you have the operational subsystem. The radio subsystem is the one that deals with the base station transceiver, which is responsible for providing the radio services in terms of allocating the radio resources and also maintaining certain types of handover. We'll talk about different levels of handover. You have handover between base station and another. You have handover between MSC and another, which means that you have moved to another city, and you have handover to move from one country to another, right? So these are different levels of handover that requires again, different types of, or different levels of management, right? So RSS or radio subsystem talks about the inter base station handover. Yani if you hand over from one base station to another, this is handled by the radio subsystem. You have the network and switching subsystem, which manages بقى اللي هي الموبile switching center. If you move from one city to another, then you have to go to the NSS level. So you have another level of handover that gets managed by the network and switching subsystem. And you have the operation subsystem, which is responsible for managing the entire network in terms of maintaining the policies of the network, like for example, or billing. So this mobile station, for example, has a plan to transfer this amount of data bits per second. So you have to monitor how the traffic looks like, and then you provision, you say, okay, so this mobile station has consumed all the data, so you don't have data anymore. This mobile station مثلا consumed data plan in a certain billing, so it also manages the billing of the data plan and so on, and it also manages the security, including the authentication and the key management and so on. So this is done by the operation subsystem. Again, we'll talk about each of these components in more detail.
To make a communication between all the components,
right?
All of them should have a same GSM.
Yes, all of them are in the same GSM, and this is a good question, because from one component to another, you will see from one component to another, the standard بقى, in addition to defining this architecture, it defines the interface between any of these components. And the interface here defines بقى what are the set of functions, what is the signal that travels from this component to another, in great details بقى. ماشي? What is the data rate here? So we will see in the architecture that between these components there are interfaces. Okay? So this interface facilitates بقى what type of signal and function are being called from one component to another, what is the data rates, and so on. So this, تفضل. So this is how the basic architecture for GSM looks like, and you will see that in 3G it's quite similar. Maybe some of the terminology, some of the names have changed, but it's quite similar. Okay, and even in 5G you will see برضو the architecture is quite similar, although some more components have been added. Okay, so again, this is the RSS or the radio subsystem, and this is the network subsystem, and this is the operation subsystem. So in the radio subsystem, we have the geographical radio support. So here you have the base station transceiver. Okay, base station transceiver اللي هي towers يعني, and the mobile stations, right? So we talked about this in 2 slides back. When we said that we have the interface between the mobile station and the base station transceiver, right? So this is the radio link that the mobile station uses to communicate with the base station tower. Okay, so you have, of course, one base station and multiple mobile stations. They form what we call a radio cell. Okay, so the radio cell provides radio services in a small geographical area, between maybe 1 meter to 500 or 1 kilometer maximum, not more than that. Okay, and from the mobile station to the base station transceiver, we have the interface. This interface provides the detailed functionality for all kind of channels, functions, data rates, and signals that go through this link, okay? To provide that data service, control information, everything, okay? Of course, as we said before, the cell is modeled through this hexagon, although it's not exactly hexagon in reality, of course, as we have discussed before. And you have neighboring cells. So these cells are neighboring, and you have to use, of course, frequency planning. Some of these cells, they use the same frequency if they are very far from each other. We talked about all of this, right? These cells could be small cells or could be large cell. You can use cell breathing, remember? We can use cell breathing by adjusting the base station transceiver with specific antennas and specific transmission power. We can increase the range, reduce the range, and so on. So of course, in dense cities, and of course in urban cities, we use smaller cells. Of course, in suburban or remote villages or something like this, we can use a large cells with because the density of users are small. مفهوم? In any case, so neighboring cells can reuse of course, these have to use different frequencies or different channels, as we will discuss later. And these are part of the radio subsystem. So here we have what we call the base station controller. Base station controller provides the handover between these cells. So if you move from one cell to another, right, you have to trigger the base station controller to manage the handover operation while the mobile station moves from one cell to another. Okay. So this interface, for example, provides data rates not more than as we said, 10 kilobits per second, things like that, right? From each of these base station subsystems to the base station controller, we have what we call A-base interface. This A-base interface supports data rates of 64 kilobits per second, which is because it's used, of course, to multiplex the transmission from multiple base stations, as you can imagine. So this multiplex transmission, this A-base interface can support data rates in the range of 64 kilobits per second. ماشي? And then from the base station controller, we have the mobile switch center. So base station controllers, you can think of it as, it actually covers a geographical area that includes مثلا 2 cells or 3 cells, okay? Remember, from the base station, this is a good question. From base station transceiver to the base station controller, it's wired. Of course, nowadays they can use microwave links, but forget this. So it's wired. So the only wireless link is here. This is the only wireless link. Other than this, everything else is wired, right? So these are in fact servers. عبارة عن switches, routers, servers.
So in the core
network? Yes, in the core network, and that covers يعني مثلا a geographical area, big geographical area. Okay, so this base station controller provides more يعني scalability and fine-tuned handover because you don't want the handover to be done very, very frequently when the mobile station moves from one big location to another. So you have another base station controller that handles this kind of handover. We call it inter-base station and intra-BSC handover. We'll talk about this. ماشي? طيب, from the base station controller, we have the mobile switching center. Mobile switching center, this is the main brain of this architecture. Because not only does it provide handover, it provides all types of radio resource management in the network, and it actually also interfaces. As you can see, the connection from the mobile switching center goes to every part of the network. So it's like the brain. So the mobile switching center connects with the location register, the visitor location register, the home location register. It connects also to the EIR, connects to the operational subsystem. So it's kind of the brain of the entire system. Okay, so it handles all types of handover, fetching information from different location registers, handles even the security functions and so on and so forth. So it's kind of the brain of the entire system. So one mobile switch center can cover a city, a big city. So in a big city, مثلا, if you have like مثلا 10 different cells, you have 2, 3 base station controllers, and you have one mobile switch center. And if you have multiple cities, you can have in one infrastructure network, you have مثلا 2 MSCs or 3 MSCs مثلا for one telecommunication network. ماشي كده؟ And of course, the mobile switch center بقى connects with home location register and visitor location register. We'll talk about the details of this. You have the home location register being the repository for the semi-permanent information of the mobile station, which includes all kind of identification numbers, including the PIN number, serial number, all of this, which are semi-permanent. And a home location register provides like a centralized repository in the entire network. So you have mainly, you may have actually more than one mobile switch center, but typically you have one home location register for the entire network that hosts all type of semi-permanent information for the mobile station. But also, you also store some temporary information, including what location area that the mobile station exists at this point of time. ماشي? So if you know the location area, then you can go to the mobile switch center of this location area, and then you start fetching all other information, and then you can page that mobile station to provide end-to-end voice call and so on and so forth. Okay, we'll talk about the details of this. One important functionality that the mobile switch center also provides is to interface to the other networks. So we said that on the other side we have PSTN, right? Public Switch Telephone Network. So if you are calling a landline, then mobile switch center will also trigger the gateway MSC, the gateway mobile switch center, to switch you to ISDN or to PSTN if you want to call a landline, okay? Or if you want to talk to another type of network, being another GSM network or another even CDMA network or any other service network of any technology, then you have to provide what we call interworking function. Interworking function provides the bridge to this other network, other type of network. So also MSC connects you with the interworking function to this other type of network if you want to call another mobile station on another telecommunication system that supports any other technology other than GSM, okay? So that's also done through the mobile switch center. تمام كده؟ So let me. Of course, the speed of the mobile station affects طبعا the frequency of the handover and affects the achievable throughput because as we talked before, there is something called Doppler effect, if you remember, and the Doppler effect gets affected by the speed of the mobile station because the speed of the mobile station affects the multipath fading and so on. So of course, this multipath fading affects the throughput, achievable throughput by the mobile station, and also the speed affects the frequency of handover. So if you increase the speed of the mobile station, then the handover happens more frequent, of course, right? Because you have more probability to move from the range of one base station to another. Okay? You will get to experience all of this in assignment 3. Any questions so far? So this is the operational subsystem, which, as we said, it maintains all kind of traffic policies. It manages all the traffic policies and billing, and also it manages all security function, including the authentication and the key management and so on. Okay. So in terms of architecture, as we said, we have the radio subsystem, and you have the network and switching subsystem. So the radio subsystem here includes the base station transceiver and the base station controller. So the base station transceiver and the base station controller together, they provide the basic radio service for the mobile station and also handle all types of handover between one base station to another within the domain of one base station controller. Okay? And from the mobile station to the base station transceiver, you have the UM interface, and from the base station transceiver to the base station controller, you have what you call ABIS interface. And that connects you to the MSC, and the MSC here the UM provides the radio interface. ABIS is standardized open interface with 16 kilobits per second user channels, and I said the ABIS, the A interface provides 64 kilobits per second. The ABIS interface provides only 16 kilobits per second. So the A standardized open interface with 64 kilobits per second user channels. Because from one interface to another, you can imagine that you multiplex multiple data streams coming from multiple mobile stations. Okay. ماشي كده؟ طيب. So continuing this, so we have the network subsystem, and you have the other types of network on the other side. So between the mobile switch center to the different type of, these are the location registers and the databases for maintaining the billing and so on. So between the mobile switch center to these types of location registers, we have another type of interface called SS7 interface. So the mobile switch center also connects with the foreign network or the destination network, which could be either PSTN or ISDN, which are natively supported in the standard, as we said, or another type of network, which could be any type of generic network, and these have to happen through what we call a interworking function. So in ISDN and PSTN, you see that there is no interworking function, right? Because they are natively supported in GSM. The standard defines how you connect to PSTN. But the standard provides this interworking function to provide any kind of bridging back to to any other technology telecom system that uses another technology other than GSM. ماشي كده؟ So we will talk about all these databases in details later, which identity or which type of information is maintained in each of these location registers and what they are used for exactly. ماشي؟ طيب, so the radio subsystem, nothing is new here. The radio subsystem here comprises the cellular mobile network up to the switching center. So this is what we call the radio subsystem. So including the mobile station, base station tower or the base station transceiver, and the base station controller. All of these three constitute what we call a radio subsystem. So this is the base station subsystem. So this is the base station transceiver, the base station controller, and the interconnection between them, and the mobile station. So this is the radio subsystem. Of course, as we said before, the cells are represented in telecommunication systems as hexagon. Of course, you can use the frequency planning. So, for example, here you can use F1, F2, F3, but here you can use F2 again because these are far from each other. So this is the type of frequency planning that you have to do. Here you can use F1 because they are far from each other. So this is the frequency planning that you need to do. As we will see later, GSM defines certain number of channels in the uplink and in the downlink, and each of these cells, they divide this number of channels so that you can assign, مثلا, 10 channels for one cell. So, which means that this frequency range is used only by this cell. But the same 10 of channels can be used by another cell and so on. So this is the frequency planning part. Inside each frequency range bar, you can divide into time slots. So we'll see how we divide the radio resources into frequency and time slots. And of course here, the cell size ranges from 100 meters. Of course, this is in urban areas and densities. All the way to 35 kilometers. Of course, this can happen only with, of course, specific type of antennas and very high transmission power. So if you use these two combinations, then you can get to very far. Of course, in urban areas, it's not advisable to use high transmission power. Why?
Because it is first multipath fading.
Yeah, yes, but
it will extend more.
Extend more, yes. So it increases the probability of multipath fading, ماشي. But more importantly, it introduces interference to the other cells, right? So because here we say that F1 and F1 here can be used because they are far. So if you're using very high transmission power, you are essentially increasing the range of the cells, so they overlap with each other. So it's not good, especially in urban cities, because in urban cities we need to use high capacity or high density of users, right? So in that case, we need smaller cells, because in smaller cells we can support high capacity of users or high density of users. طبعا hexagonal shape here is idealized. We talked about this. If a mobile user changes cells, we call it handover. We have different types of handover that we will talk about, and we have seen that graphically, and we see how we can handle handover in terms of frequency, in terms of how we handle the resources from one cell to another, and so on. طيب خلينا نستوب هنا عشان ندي فرصة للدكتور علاء